40 light-years from Earth, a single small star hosts something astronomers had never seen before: 7 Earth-sized worlds orbiting in near-perfect harmony. TRAPPIST-1 is a small, dim red dwarf star located about 40 light-years from Earth in the constellation Aquarius. It is much smaller and cooler than our Sun, only slightly larger than the planet Jupiter. Despite its small size, astronomers discovered it hosts 7 planets, all roughly similar in size to Earth. The system was named after the Transiting Planets and Planetesimal Small Telescope that first detected it in 2016. Astronomers found the planets by watching the star's light dim slightly each time a planet passed in front of it. This transit method allows scientists to detect distant planets without ever seeing them directly through a telescope. All 7 planets orbit closer to their star than Mercury orbits our Sun, yet many remain temperate due to the star's dimness. The planets are tidally locked to their star, meaning one side always faces the star while the other remains in permanent darkness. This creates extreme conditions, with one hemisphere potentially scorching hot and the other frozen in eternal night. 3 of the 7 planets, named E, F, and G, orbit within the star's habitable zone where liquid water could exist. The habitable zone is the region around a star where temperatures could allow liquid water to persist on a planet's surface. Because TRAPPIST-1 is so dim, its habitable zone sits much closer to the star than Earth's distance from the Sun. All 7 planets are so close together that if you stood on one, neighboring planets would appear larger than our Moon in the sky. This unique configuration means an observer on one planet could watch cloud patterns move on the neighboring worlds. The planets are so tightly packed that their orbital periods form a rare, precise mathematical relationship called resonance. This resonance chain is so precise that astronomers can predict eclipses and transits with remarkable accuracy. Scientists believe this level of resonance suggests the planets formed farther out and migrated inward together over time. The James Webb Space Telescope has directly studied several TRAPPIST-1 planets, searching for signs of atmospheres. Early observations of the innermost planets found no evidence of a thick atmosphere, suggesting they may be barren rock. This was somewhat disappointing news, as thick atmospheres are considered important for maintaining surface habitability. Red dwarf stars like TRAPPIST-1 are known for producing intense flares that could strip away planetary atmospheres over time. This raises serious questions about whether planets around red dwarfs can remain habitable over long periods. However, red dwarf stars like TRAPPIST-1 can live for trillions of years, far longer than our own Sun's expected lifespan. This extended lifespan could theoretically give life much more time to develop, even if conditions are initially harsh. Red dwarfs are also the most common type of star in the entire Milky Way galaxy, making up about 75% of all stars. This means systems similar to TRAPPIST-1 could be far more common throughout the galaxy than Sun-like star systems. If life can survive around red dwarfs, it could dramatically increase the number of habitable worlds across the galaxy. Scientists continue to study outer TRAPPIST-1 planets F and G, which may retain thicker atmospheres due to more distant orbits. These outer worlds receive less intense radiation, potentially allowing them to hold onto protective atmospheric layers. The discovery of TRAPPIST-1 fundamentally changed how astronomers search for potentially habitable worlds. Before this discovery, scientists largely focused their search efforts on stars similar to our own Sun. TRAPPIST-1 demonstrated that small, dim stars deserve serious attention in the search for life beyond Earth. The system remains one of the most studied exoplanet systems in astronomical history due to its unique configuration. Future telescopes are being specifically designed to analyze the atmospheres of planets like those around TRAPPIST-1. These instruments will search for biosignature gases such as oxygen, methane, and water vapor in exoplanet atmospheres. Detecting these gases in the right combination could provide strong evidence of biological activity on a distant world. TRAPPIST-1 is close enough, astronomically speaking, that detailed study remains within reach of current and near-future technology. At 40 light-years away, any message we sent today would take 4 decades to arrive, and another 4 decades for a reply. Despite this vast distance, TRAPPIST-1 remains one of humanity's best current targets in the search for life beyond Earth. The system captures public imagination because it offers a complete miniature planetary system unlike our own solar system. Artist illustrations of the TRAPPIST-1 system have become some of the most iconic images in modern astronomy. Scientists continue to refine their models of each planet's potential climate, composition, and habitability prospects. Every new observation adds another piece to the puzzle of whether any of these 7 worlds could support life. Whether or not life exists on any of its 7 worlds, TRAPPIST-1 has shown us that entire families of Earth-sized planets can form around stars unlike our own, quietly waiting 40 light-years away to be understood.